Hello everyone, welcome back to my channel. In this video, I'm going to explain the topic salt analysis. This is a very important practical experiment in grades 11 and 12 chemistry. And in the board exam for the grade 12 students, salt analysis carries 8 marks out of 30. So it is very important that you learn this experiment very well. Now, salt analysis is a humongous topic. So, if I explain all the tests involved in salt analysis in one video, it will definitely be confusing and difficult for you to remember. So, what I'm going to do is I'm going to split this topic into 4 or 5 parts, and in each part, I will cover a specific set of tests so that you can learn part by part. So this is part number 1 for salt analysis, and in this video I'm going to explain the first set of tests which you need to remember for salt analysis, and this is important for grade 11 as well as grade 12. And for the grade 11 students, initially it might be quite difficult to remember all the tests because you are new to this kind of practical experiment. But of course, with time and practice, you will definitely get used to it and you will remember all the tests by the end of this the series of videos. So I will upload all the parts very soon. So this is part number 1. I will record the other parts and upload it as soon as possible so that you can go through all the videos and be thorough with this topic. Now, in salt analysis, what is the aim? Why are we actually performing this experiment? What is our objective? You need to know that. So, the aim is to identify the anion and cation present in the unknown given salt. So, in the exam, what they are going to do is they are going to give you an unknown salt, and you need to identify what are the ions present in the salt. And to identify that, you need to use certain characteristic tests which are compiled together under the name of salt analysis. So, it is basically in salt analysis, there is a huge set of tests which you need to remember, and these tests will help you identify the anion and cation present in the salt. Now, you need to understand how the anions and cations are classified based on groups. So, that I am going to explain first. So, we need to first understand how we can classify the anions. Now, anions are also known as acid radicals. They are known as acid radicals. So, the classification of acid radicals can be done by dividing the anions into 3 groups, which are group 1, group 2, and group 3. Now, in group 1, you have carbonate ion and acetate ion. In group 2, you have chloride, bromide, iodide, and nitrate ion. In group 3, you have sulfate and phosphate. So, this is the order in which we are going to identify the ions. So we need to perform the tests for all these ions until we reach a positive test for one of the reactions. So basically all the ions react with a certain chemical, and you need to get a specific observation. So what we are going to do is we have to perform the tests for all the anions and see where we are getting a positive reaction. So when we get a positive reaction for a particular ion, we can understand that that is the anion present in the salt. Once you identify the anion, of course you need to confirm your identification, because there are chances of error, because maybe because of certain temperature conditions, or maybe you might have used the wrong chemical. We don't know what could have gone wrong, so there are slight chances of error in your observation. So just to confirm that what you have identified is correct, you need to do another test which is known as the confirmatory test. This is common for anions and cations. Even for cations, there are certain identification tests which we need to do. And once we identify the cation, we need to do another test to confirm that what we have observed is right. Now, you need to understand that there are so many ions involved in salt analysis. In CBSE, we are only learning a few ions. Now, actually, there are many more ions in addition to what I have mentioned here on the screen. Like you have sulfide, you have sulfite, you have nitrite, and so on. You have many ions. However, I am going to explain only these ions what I have mentioned in the table, because these are what I had learned in my school, and I think these are the commonly asked ions in the board exam as well. However, if you do want me to explain the other anions, let's say in your school they are giving you another anion as well in the salt, then you can please share that ion in the comments, and I will make another video where I will be explaining the identification and systematic test for that ion. So please feel free to comment if your school is doing any other ion. I am aware that certain schools are doing other ions, but these are what I had learnt in my school. And of course, if you need me to explain the other ions, please feel free to comment. Now, let's start with the anion systematic tests. So, I told you I'm going to split this topic into 4 or 5 parts. In this part, I'm going to cover the systematic tests for anions. And also, I'm going to do the preliminary analysis, preliminary observations. Now, what do you mean by systematic tests? Systematic test is another word for identification test. So, I told you we are going to perform the test for all the ions. We need to go in a sequential order. We need to follow this order what I have mentioned on the screen. This is the order that we need to follow, and this order you should never change, because this has been identified by the chemists. Because see, why are we actually having this order? For example, I'm just giving you an example. It is not scientifically proven or anything, but I'm just giving you an example to understand why this order is important. Now, let's say there is chloride ion. Chloride ion may show a positive test for the ions which are coming after it. Like it may show a positive test for the nitrate test, or it may show a positive reaction for the sulfate systematic test. So, in order to eliminate the chances that the positive test could be because of chloride, what we are doing is we are using a test in advance to eliminate the chances that if you are getting a positive reaction for nitrate or sulfate, we are eliminating the chances that it could be because of chloride. So, in order to eliminate that, we are performing a reaction before doing the nitrate and sulfate test. And if you are getting a positive reaction for that, that means your ion is chloride. So, if you are not getting a positive reaction for this chloride test, then if you are getting a positive reaction for the nitrate test, then there is no chance that it is chloride. Because if the ion were chloride, then it should have given a positive reaction even for this test. I hope I'm making sense. This is not at all important. I'm just making you understand why this order is significant. And of course, the halides are actually having the same priority. There is no difference in the halides. All the halides are of same priority, and there is only one single test. But of course, the observation will be different. So in salt analysis, I told you first we are going to discuss the preliminary analysis or the preliminary observations. What do you mean by preliminary observations? Preliminary observations are the observations that you can find out without doing any chemical test, without adding any sort of chemical or doing any reaction. You can identify the certain clues about the ions present in the salt. So the first one is the color of the salt. Now, in your exam, mostly the color of the salt is going to be colorless. That means it is going to be white. The reason is because if they give you a colored salt, you can easily identify the cation of the salt. So ideally in the exam, they are not going to give you any colored salt. But if they do, I will tell you what are the conclusions that you can draw from it. So if your salt is colorless, then you can say that the following ions are absent: copper or cupric ion, ferrous ion, ferric ion, cuprous ion, nickel ion, cobalt ion, and manganese ion. These are the ions which are found in colored salts. So if your salt is colorless, then you can say all these ions will be absent. So there is no chance that these ions are present. Now, let's say you are getting a colored salt. Then that means one of these ions is going to be the cation. So let's say you are getting a blue salt. If your salt is blue, you can say that it is copper. If your salt is green, you can say the ion present is ferrous ion. If your salt is reddish brown, then you can say the salt is cuprous or ferric. Either cuprous or ferric. If your salt is dark green, or to be specific, you can say emerald color. If your salt is emerald in color, then you can say that the cation might be nickel. If your salt is red, or you can say dark shade of pink, then you can say this the cation is cobalt. And if your salt is pink, you can say it is manganese. And when I say pink, it is not a dark shade of pink. It is a very, very faint shade of pink, a very light and subtle pink color. It is not very dark, and it actually from afar you may think it is white, but if you look closely you can see a light hint of pink in it. So if you're having a light pink salt, then it might be manganese. Now I am going to tell you what you need to do when you are writing this in the record book or in your exam. Now I have just written color, colorless, absence. That is just I just wrote it while explaining. Now when you are writing it in the exam, you need to write in proper sentences always. So the first you have to write in the see, actually there are three columns when you're writing. One is experiment, then you have observation and inference. So in the experiment column you need to write what you are performing. In the observation column you have to write what you can observe, and in the inference column you need to write your conclusion from the observation. So in the experiment column you need to write color of the salt is noted. In the observation column you need to write the salt is colorless. And in the inference column you can actually write absence of all these ions, but since we prefer complete sentences, you can just write absence of all these ions is noted. You can write is noted at the end, or is observed, whatever. Any word can be used, but ensure that you write everything in complete sentences. Don't just write especially for the observation, don't just write the observation in one or two words. You have to write it in complete sentences in the exam. Now, the second preliminary observation is the odor of the salt. Now, there are two characteristic odors which you may observe. The first one is ammoniacal odor, and the second one is vinegar odor. Let's say you are getting a vinegar odor. Then you can say the anion of your salt is likely to be acetate. And if you are having an ammoniacal odor, then you can say the cation is likely to be ammonium. Ammonium is NH4 plus. You have been studying that since grade 9. So now, let's say you don't know what is ammoniacal odor. Of course, for the grade 11 students, it is something that is going to be new because you have never experienced the smell of ammonia. So if you are confused about the odor, what you can do is, in your school there is definitely going to be NH4OH, ammonium hydroxide will be there because you need it for salt analysis in the tests. So just take a watch glass and add a few drops of this NH4OH in it and smell it. That is going to give you the smell of ammonia, and that is what is known as ammoniacal odor. Or you can even take NH4Cl, ammonium chloride, and you can add water to it. And if you add water, you will get NH4OH again as one of the products, and you will still get the ammoniacal odor. So these are the two characteristic odors. Again, you need to write it in the record and in the exam in proper sentences. So you need to say a vinegar odor is observed. So like that, you have to write in complete sentences. And the last preliminary observation is the solubility. Now, for solubility, you do need to add certain chemicals to the salt. However, it is not a proper test because you are not going to get a a very clear idea about the ion. It's just a rough it's just a rough guess. Now, what you are going to do is, as the name suggests, you need to check whether the salt is soluble in certain liquids. And the two liquids are water and dilute HCl. So you are going to take the salt in a test tube and you are going to add, first you're going to add water. Now, mostly your salts are going to be water soluble because all the salts do dissolve in water. You are not going to get a water insoluble salt, but if you are getting a water insoluble salt, then definitely that ion is you are making a mistake because all the ions in salt analysis do dissolve in water. So whatever salt you get, it will definitely dissolve in water. Now, to this water solubility test, you need to do a second part. So what is that second part? Once you observe that the salt is soluble in water, you need to add sodium carbonate, Na2CO3. Now, when you add Na2CO3, you have to see whether your salt is forming a precipitate. If you are not getting any precipitate, no PPT, then you can say that the ammonium ion is absent in your salt. Ammonium ion is present. I'm sorry, I'm mixing my words because it is something new for me, this YouTube channel. So initially I am making lots of errors while speaking, but I think I will get used to it. So I apologize for all the confusion that I'm causing. But what I meant is NH4 is present. Okay, so if you are not getting any precipitate, then NH4 plus ion, ammonium ion is present. Second, you need to take the salt and add dilute HCl. Now, if you are getting, if it is soluble, then you can say that lead ion is absent. So, very important. First, you have to take the salt and add water. If it is soluble, you need to add sodium carbonate. And if you're not getting any precipitate, then NH4 plus ion, ammonium ion is present. Let's say you are doing the dilute HCl test. If you're doing the dilute HCl test and if you see that the salt is soluble in it, then you can say that lead ion is absent, because lead salts will form a white precipitate with dilute HCl. So if it is soluble and there is no precipitate being formed, that means lead is absent. Okay, so I hope this is clear. This is all about the preliminary observations. There is another preliminary observation known as flame test, and also there is dry heating test, but the dry heating test is not required in the exam. And the flame test, even though it is something which you need to write in the preliminary observation, you don't have to perform it unless the examiner tells you to perform the flame test first. You don't need to do the flame test. The flame test is actually a confirmatory test for the cations, and I will be explaining the flame test in that video where I'm going to explain the confirmatory test of cations. In this video, we are not doing that, so I am now going to explain the flame test here. But let's say in case in your school, your teacher has told you to write flame test in the preliminary observations, then please go to the the part where I am explaining the flame test, and you can learn the flame test from that, and you have to write it in the preliminary section. So now in this video, we are going to start with the first set of tests, and that is the identification test for anions. So you can write the heading identification, or you can even say systematic. So identification tests for anions. And I already told you what are the anions that we are going to discuss. So you can be prepared. So now you can listen with attention, because I'm going to explain the chemistry behind each of the reaction as well. And this chemistry, what I'm going to explain, is very important for your Viva, because in the Viva, they are likely to ask you what I'm going to mention under the chemistry section. So what do you mean by chemistry behind the reaction? It is basically something in addition to the observation, something what we are actually, for example, let's say you are getting a vinegar smell in something. Okay, so when you're performing a reaction, you are getting a vinegar smell. In your record or in your exam, you are going to write a vinegar smell is observed. But what is causing that vinegar smell? That is known as the chemistry. What is the product formed? What product is actually giving off that vinegar odor? That is going to be known as your chemistry, and that you don't need to mention in your exam, but you need to have a general idea of it, because in your Viva, the examiner is bound to ask that. So first we have to do the group 1 anions. So you can write group 1, okay, Now, first we need to do the test for carbonate. First, a clue that I'm going to give you is for the identification test for anions. Remember, we are using the salt in everything. We are not using salt solution. We are using salt, just the plain salt we are going to use, and to the plain salt we will be adding certain chemicals. There is only one ion which involves salt solution, and I will explain why that particular ion needs salt solution. But for the other ions, please remember, for the identification test you just need to use the plain salt. So first, group 1, we are learning about carbonate and acetate. So first we have to discuss carbonate. For carbonate, what you can do is, to the salt, you need to add dilute HCl. Again, I am repeating, we are adding dilute HCl to the salt. We are always performing the test for identification for anions using the plain salt. Remember this, plain salt. Only one ion requires salt solution, and I will be telling you why that ion requires it when I reach that. So to the salt you are going to first add dilute HCl. Now if you are getting a colorless and odorless gas evolved, if a colorless odorless gas has been liberated, then you can say that this is carbonate ion. Okay, carbonate ion is present in the salt. Now, the colorless odorless gas, if you need to verify that it is actually carbonate, you can also do another step to verify that this is carbonate. So what you can do is this colorless odorless gas you can pass through lime water. Now what is lime water? Lime water is aqueous calcium hydroxide. Aqueous calcium hydroxide is known as lime water. Now, ideally, you don't need to do this lime water part, because lime water, if you are reacting with air, it will react with carbon dioxide and it will form calcium carbonate. So instead of that, you can just look at the colorless odorless gas, and if you're seeing brisk effervescence, what is brisk effervescence? Brisk effervescence is bubbles, the bubbles that you can see on top of the solution is known as brisk effervescence. And brisk effervescence means there is certain gas being evolved. So if you are saying brisk effervescence and the gas is a colorless and odorless gas, then you can say that the ion present in the salt is carbonate ion. And if you are having lime water in your lab, then you can do the lime water test. But ideally doing this test is difficult, because if you are using a test tube to do this, then it will easily react with carbon dioxide in the air, and you will immediately see that the lime water will turn milky because of the because it will form calcium carbonate. Now, what is this colorless odorless gas? The colorless odorless gas is nothing but carbon dioxide. So that is why I told you it is better not to do the lime water part, because lime water will easily react with CO2 from the air itself, because you know in the air there is carbon dioxide. So it will easily react with carbon dioxide in the air, and it will automatically turn milky. It will turn white in color, and you will mistake that for the presence of carbonate. But actually you need to do this test with the colorless odorless gas. So that is why I recommend not to do the lime water part. You can just see if there is a brisk effervescence and a colorless, odorless gas is being evolved, and if it is so, then that gas is carbon dioxide, and the ion present in the salt is carbonate ion. I hope this is clear. The second ion in group 1 is acetate. For acetate, what you need to do is, to the salt, you need to add dilute H2SO4, dilute sulfuric acid. Now this you need to perform in a watch glass. The reason is because you are actually going to test for an odor. And of course, the mouth of a test tube is very narrow, so you may not be able to identify the odor easily. So it is better to use a watch glass because the mouth of the watch glass is quite big and you will be able to observe the odor better. So you need to add dilute sulfuric acid to the salt in a watch glass, and you need to rub it with a glass rod. And if you are able to get a vinegar smell, a vinegar odor, then you can conclude that the ion present in the salt is acetate. Again, this is the identification test. I told you in the beginning itself, you need to confirm your identification, and those tests we are not learning in this video. We will be learning in the next part where I'm going to tell the confirmatory tests. Here we are just learning how to identify the presence. Now, why are you getting a vinegar smell? What is the vinegar smell? The vinegar smell is because of the formation of ethanoic acid. Ethanoic acid or acetic acid is present in vinegar. So when you are getting the vinegar smell, it is actually because of the production of acetic acid. So why do you think this is happening? You know, in grade 10, you have studied when salt reacts with an acid. When a salt reacts with an acid, you are going to get a double displacement reaction and you will get a new set of products. So let's say I'm having a metal acetate salt. Let's say CH3COO, and there is a metal. I'm not considering an example. I'm just saying in general, some metal is present. When I am adding H2SO4, there is going to be a double displacement reaction. That means the positive ions are going to get exchanged. So this metal will go to the sulfate ion and the hydrogen ions will go to the acetate ion. So you are going to get a metal sulfate salt, and you will also get acetic acid. So whatever metal is present in the salt, you will undergo this reaction. This reaction will be present and you will be able to see the formation of acetic acid. And this acetic acid is responsible for the vinegar odor which is being released from the test tube, from the watch glass. And you know that acetic acid is found in vinegar, which is why you are able to get that kind of odor. So that is the chemistry behind this reaction. So now we are done with the group 1 anions. Now we have to go to group 2. So group 2, I have told you in group 2 we have the halides and we also have nitrate. So first let's do the halides. In the halides we only need chloride, bromide and iodide. We are not analyzing for fluoride. There is no fluoride salt in the lab. I don't think it will be there in any of the schools. So we are not going to analyze for fluoride because the reactions of fluoride salts are violent. Now let's learn the test for halides first. So you need to perform the test for halides first. So I told you you need to use the salt always except for one ion, and for group 2 you don't need to worry about all that. You have to use the salt. So to the salt, what you need to do is you need to add concentrated sulfuric acid. Now, if you are using concentrated sulfuric acid, you will have to be very careful because it is a very, very harmful acid and it is concentrated. So, definitely it is corrosive. So, be very careful. Use a dropper, and when you're holding the test tube, also please use the test tube holder. Now, you need to take the salt in a test tube and add concentrated sulfuric acid. Now, very important mistake that students often make is that they will be heating the test tube. Please understand, when you're adding concentrated sulfuric acid, for this test, you don't need to heat it. The observation that I'm going to tell you has to be found without heating. So if your salt contains a halide in it, then it will react with concentrated sulfuric acid without the presence of heat. You don't have to heat the test tube. So if you are not heating the test tube and you are still getting the observation that I'm about to tell you, then you can identify that, or you can say that a halide ion is present. So what is the observation? The observation is you have to get a certain, you have to get some vapors, some gas has to be evolved. Now, what is the color of the gas? Now, if you are getting a colorless gas, then you can say that it is chloride. If you are getting a reddish brown gas, then you can say it is bromide. And if you are getting violet vapors, then you can say it is iodide. So, how to remember this? Now, the colorless gas for the chloride ion is actually going to have a very pungent smell. You have to experience that once to identify that it is chloride. So, sometimes you may see there is a gas evolved, but you will not get any pungent smell. That means your salt is not chlorine. You have to get colorless, or you can say white fumes from the test tube, and the smell from the test tube has to be very pungent. You can say, so you have to get a pungent smell to say that it is chloride. Now, how to remember this? I will give you a clue. C for colorless, C for chloride, B for brown, B for bromide, and the other one is iodide. So you can remember B for brown, B for bromide, C for chloride, C for colorless, and the last one, the violet one, is for iodide. And you are aware of the starch test. When you're identifying the starch test, with iodine, you will get a purple color if it is starch. So you can remember that, and you can say that the color of the fume is violet, because even for the starch test you need a violet color to conclude it is starch. So you can use that to remember it. And the violet vapors are going to be very deep. It is going to be a dark shade of purple. So from afar, it may look like reddish brown gas. But if you look closely, at the side of the test tube, you can see it is actually a dark shade of violet or purple. Now, the next ion is nitrate. Before that, I need to do the chemistry behind the reaction. So, what is the chemistry, or what you need to learn for your Viva. So for the Viva, you need to know what are these vapors that are being evolved. Now for bromide ion, the reddish brown vapors are due to the liberation of bromine gas. And for iodide, it is because of iodine gas. Iodine gas is violet in color. And the violet vapors are due to the liberation of I2. But remember, this is where everyone makes mistakes. Since bromide and iodide are having the gases as bromine and iodine, you may think that for chloride the colorless gas is Cl2, but that is wrong. It is not chlorine gas. Chlorine gas is actually yellowish green. It is not colorless. So this colorless gas, what you can see for chlorine is actually hydrogen chloride. HCl gas is being evolved. So this is very important, and in the Viva you may make mistakes, so please be careful. For chloride, the colorless gas that is being evolved is HCl, but for bromide and iodide, the gases are bromine and iodine respectively. Next you have nitrate ion. For nitrate ion, very important, please don't throw or discard the substance in the test tube. Please don't do that. Once you are done with the halide test, and if you are not getting any vapor, let's say you are not seeing a colorless or reddish brown or violet vapors coming from the test tube, then please don't discard the test tube, because you need to do the nitrate test with this concentrated H2SO4 in it. So if you are not getting any characteristic vapors, what you can do is you have to heat the above mixture. And once you heat it, so this above mixture you need to heat. And once you heat it, you have to add a paper ball, or you can even use copper turnings. So you can use copper turnings, or you can use a paper ball. So the paper ball will not be made in the lab, like it will not be ready made. There will be paper strips, some filter paper strips, and what you need to do is you need to crumple it into a ball, and that paper ball you need to add to the test tube and heat it. And if you are getting a brown gas after doing this, then you can conclude that the ion in your salt is nitrate. So this is the identification test. Now what is the brown gas being evolved? That is the chemistry behind the reaction. So the brown gas being evolved is nitrogen dioxide. You have studied in grade 10 that nitrogen dioxide is brown in color. So this brown gas which is being liberated is actually nitrogen dioxide, which is why the ion that is present is nitrate. Now we are going to group 3. Now in group 3 we have sulfate and we have phosphate. Now for sulfate, now I was talking about one ion which requires salt solution instead of salt, and that ion is none other than sulfate. Now sulfate is very important because sulfate salts, when you are analyzing for sulfate salts, you are going to perform a double displacement reaction. Now what you need to understand is, for double displacement reactions, the reactants have to be in aqueous state. That is something that you have learnt in grade 10. In grade 10, when you learnt in chemical reactions and equations chapter, you have studied that in a double displacement reaction, except for the precipitate, let's say you are getting a precipitate, it's a precipitation reaction. Then in a precipitation reaction, other than the precipitate, everything else, all the other products and all the reactants are going to be in the aqueous state. Only the precipitate is a solid residue. Everything else is it's in aqueous state. So that is the reason why you need to use salt solution, because salt is a solid. So we need the salt to be in aqueous state, for which you need to add water. And this is known as water extract, or in simple terms, it is salt solutions. Basically, salt solution is salt plus water. So in the test tube, the only difference is you need to take the salt and add water to it. There will be distilled water in the lab, so you need to add distilled water, and once you use that, you will see that the salt is dissolved. So you have to shake the test tube, of course, and make the salt dissolve, and once it is dissolved, you have to add the chemical. That is the only difference. So in all the previous tests, we were using just salt, but for sulfate alone, you need to use salt solution. So to the salt solution or water extract, what you can do is you have to add barium chloride. Barium chloride you need to add, and once you add barium chloride, you can see that a white precipitate will be formed. It is a double displacement reaction. It is a precipitation reaction. So you will see a white precipitate is being formed. And for the chemistry, what is this white precipitate? They can ask you in the viva. So the white precipitate formed is nothing but barium sulfate, because as I told you, it is a double displacement reaction. So I will tell you what happens. So when you are adding barium chloride to a metal sulfate salt, what you need to understand is the positive ions will be exchanged. So barium will come with the sulfate ion, and the metal will be reacting with chloride ion to form a metal chloride salt. So that is why you are getting barium sulfate, and barium sulfate is a white precipitate. You have learnt that in grade 10, which is why that is the reason why you are actually using the salt solution, because we need this double displacement reaction to happen. Even the barium chloride is going to be in aqueous state. So you can see in the lab, the barium chloride will be in the form of a solution. So you need to add barium chloride solution to the salt solution, and if you are getting a white precipitate, then that means your ion is sulfate. And also one more thing, you just by getting a white precipitate, you cannot conclude that it is sulfate. There is one more step that you need to do. So what you need to do is you have to add excess amount of dilute HCl. You have to add excess dilute HCl to the white precipitate, and if the precipitate is insoluble, if it does not dissolve in excess amount of dilute HCl, then you can conclude that your ion is sulfate. So very important, once you get a white precipitate, you need to add dilute HCl to the precipitate, and if the salt is insoluble, that means your ion is sulfate. So I hope that is clear. Now the next ion, the last anion, is phosphate. So for phosphate, what you need to do is you need to take the salt. Again, here we are using just the salt. Only for sulfate we are using salt solution. So to the salt, we need to add concentrated nitric acid, and you need to add ammonium molybdate. Ammonium molybdate solution. So what is ammonium molybdate? Actually, it is a mixture of ammonium and molybdenum. Molybdenum is an element of the periodic table. It is a D block element. It is the 42nd element of the periodic table, I believe, and this solution you need to add to salt plus concentrated nitric acid. When you are adding these chemicals to the salt, you will be seeing a canary yellow precipitate. If you are able to see a canary yellow precipitate, what is a canary? Canary is actually a bird, and canary yellow is a particular shade of yellow. You don't have to be very specific, you can just even say yellow precipitate. So if you're getting this yellow precipitate, then that precipitate is ammonium molybdate phosphate. And this confirms the presence, not confirms, sorry, this is the identification test for phosphate ion. So you can say that the ion present is phosphate, and of course you need to confirm it. So in this video, that is all I'm going to explain. We discussed the classification of acid radicals. Then we discussed the preliminary observations in salt analysis, and we did one of the major headings in salt analysis, that is the identification or systematic tests for anions. And I will just summarize everything quickly. So first we have a carbonate ion. So to the salt you need to add dilute HCl, and if you're getting a colorless, odorless gas with brisk effervescence, then that gas is carbon dioxide, which indicates that carbonate ion is present in your salt. Second, you need to take the salt in a watch glass and rub it with dilute H2SO4, and if you're getting a vinegar smell, then that means acetate ion is present, and the vinegar smell is due to the evolution of acetic acid. Then you need to take the salt in a test tube and you need to add concentrated sulfuric acid. And if you are getting a colorless gas in with a pungent smell, then that means chloride ion is present. If you are getting reddish brown vapors, then it is bromide ion. And if you are getting violet vapors, it is iodide ion. And what are the vapors? The colorless gas is HCl, the reddish brown gas is Br2, and the violet gas is I2. Then if you are not getting any characteristic vapors, then you need to heat the test tube and add a paper ball, or you can even use copper tonics. And if you are getting a brown gas being evolved, then the brown gas is nitrogen dioxide, which indicates that nitrate ion is present. Then moving on to group 3, we have sulfate and phosphate. So for sulfate, you need to take the salt solution, not salt. You have to use salt plus water and dissolve the salt in the water completely. That is the salt solution or water extract. And to that, you need to add barium chloride. And if you're getting a white precipitate, which is insoluble in excess dilute HCl, then you can conclude that the ion is sulfate. And the last one is phosphate, for which you need to take the salt and add concentrated nitric acid and ammonium molybdate solution. And if you're getting a canary yellow precipitate, that precipitate is nothing but ammonium molybdate phosphate, and you can conclude that your ion is phosphate. And for sulfate, the white precipitate is barium sulfate. So I hope that is clear. So with this, we are done with part 1. So stay tuned. I will upload the other parts of salt analysis soon. And also I am aware that I need to upload the functions video. I am yet to record that, so I will upload the functions video as well for the grade 12 mathematics students. So thank you everyone, and stay tuned, and all the best. If you like this video, please give it a thumbs up and share it with your friends. Thank you everyone.